Hi, and welcome to Del Mar Learning's Residential Construction Academy for Carpentry. My name's Rodney. Over the course of this 8-part series, we're really going to be putting your carpentry know-how to the test as we quite literally build a house from the ground up right here at this construction site. You'll learn about personal safety requirements and the correct methods for using the tools of the trade. Terms and concepts surrounding carpentry will begin to make a lot more sense. And of course, we'll be giving you plenty of useful hints and tips along the way. After viewing all of the programs in this series, you should come away with a thorough understanding of what it takes to build a residential home.
Now, as you look around this job site, it probably won't take you very long to figure out that we are, in fact, somewhere in the southernmost half of the United States, which means that a portion of the content covered in this series will reflect southern building practices. However, since most of the content covered in this series is universal to carpentry, we'll also be working at a secondary location in the Northeast as well. And when we do find practices that involve geographic considerations, we'll make sure to point out those to you. So let's get started.
In today's program, we're going to start with an empty lot and take a closer look at the building layout process. Understanding the terms of the trade are one of the keys to understanding the concepts of carpentry. So, as we step through today's lesson, be on the lookout for these important carpentry buzzwords.
Building permit, plot plan, setback, transit level, 3-4-5 method, Pythagorean theorem, benchmark, water level, laser level, ledger, batter board.
So, here we are at an empty lot that appears ready for construction. Now, the site could very well be ready, but the question is, are we ready? Before taking one step on that empty lot, we should have one thing on our mind, and that's personal safety.
OSHA, the Occupational Safety and Health Administration, requires that you wear personal protective equipment whenever you're working on an area where the possibility of danger exists.
Now granted, the danger you'll likely encounter while laying out a house is minimal. However, you still need to wear sturdy shoes with hard soles, a hard hat, a pair of safety glasses, and when necessary, hearing protection and a particulate mask. You should also dress for the weather. If you're working outside in the deep south during the month of July, you're going to see a lot of crew members wearing carpenter shorts and hopefully some sunscreen as well.
However, whenever you're performing a task that could be harmful to exposed skin, it's recommended that you wear a pair of long pants, a long-sleeved t-shirt, and a pair of waterproof gloves.
When I think of skin irritation, one job that immediately comes to mind is working with concrete. By the way, it's also a good idea to have lots of water on hand as well. Dehydration can lead to stomach cramps, dizzy spells, and possibly to an accident as well. So, work smart and think safety first. This is a building permit, and before any work can begin, we're going to need to obtain and post one of these permits. The application process varies depending on the location, but it usually requires a workable set of plans by a licensed architect or engineer, along with a plot plan or survey.
Other issues that get taken into consideration include code compliances, utility locations, drainage, and of course, environmental implications.
Once you've obtained a building permit, you need to post it in a highly visible location on the job site, where it needs to remain until construction is completed.
The first task in preparing a lot is clearing the area of any buried organic debris. After this preliminary work has been finished, some sites will have fill brought in order to raise the elevation of the building. Once the fill has been dumped, it needs to be leveled and compacted. Compacting the fill prevents the ground from settling in the future. After the fill has been added and compacted, compaction tests are performed. And once these tests have been successfully completed, you're ready to start laying out the house.
We just need to figure out where the house is actually going to be located. How do we determine where to place a house? For that information, we turn to the plot plan.
A plot plan shows us a bird's eye view of the lot, as if we were looking down on the lot from up above. It shows the proposed position of the building, along with other relevant information, including things like walks and driveways. Some builders use the term site plan when referring to this document.
All right, let's locate our house. First, look at your plot plan and find the setbacks. A setback is the distance from a property line to the building. But how do we know where the property line lies? And no, guessing is definitely not an option.
Fortunately for us, surveyors mark property lines with stakes at the corners. So first we'll need to find those stakes and using string mark the boundary lines. A metal detector is a very useful tool for locating metal stakes. In order to establish the location of the house, we make our way to the front property line and measure the setback distance from the property line to the front of the house in two separate locations. Once that's finished, drive a stake and stretch a line to establish the front edge of the house. Then we'll repeat the same process to establish the rear edge of the house.
Okay, we've established the front and rear setbacks. Now we're going to need to find the side setbacks. We'll start at the front of the building and measure in from the side property line.
When you're doing this, remember to choose a location on the side property line that's in line with the front property line. Once you've done that, measure the setback distance from the property line over to the front corner of the building. This should give you the exact location of the setback. So drive a stake and place a nail at the top. An 8-penny finishing nail works well for this job because the head of the nail is about the same diameter as the string line. From this nail, measure the dimension of the building along the building line. This will allow you to establish the exact length of the building. So, once again, drive a stake at the exact location and place a nail.
Alright, we're almost done. All we have left are the last two corners, and we have a few methods at our disposal for calculating the corners. Among them are the transit level and the 3-4-5 method. Let's take a look at each of these methods, one at a time.
A transit level is a telescope with a spirit level mounted on the top. The level can be rotated 360 degrees or tilted up and down. When set up properly, a transit is capable of giving you very accurate readings. You just need to make sure that you're deliberate and patient during setup. Let's begin. First, adjust the legs of the tripod to a comfortable height, making sure to tighten the adjusting screws as you go. This will keep the tripod from slipping. Next, center and level the tripod over one of the front corner nails. Spread the legs of the tripod apart and firmly place the feet in the ground. Be sure that the tripod is directly over the front of the building. We want to work smart here, so before trying to mount the transit, make the tripod as level as possible. This is going to make adjusting the instrument that much easier later on.
When removing the transit from its case, please keep in mind that you're not pulling on a bag of cement. This is a very sensitive piece of equipment, and when you're lifting it, hold on to it from its frame, not the scope.
After you've established a stable, level platform for the transit, secure it to the top of the tripod. Next, place a plumb bob directly over the nail in the corner stake. Look under the transit for a hook, and once you've found it, hang the plumb bob from that hook. Now it's time to center up the leveling bubble, and in order to do this, you'll need to adjust the leveling screws. Begin by turning the screws in opposite directions, using your forefinger and thumb. When rotating a leveling screw, the bubble will always move in the same direction as your left thumb. After the level bubble is centered, rotate the scope 90 degrees, and as you do so, keep an eye on the bubble to make sure that it does, in fact, remain centered.
Alright, now that we've got a stable and level transit, let's take a closer look at the focus knob and eyepiece and make any necessary adjustments to those pieces as well.
The first thing you'll want to do is direct the telescope over the stake that you intend to shoot. And once you're there, adjust the focus knob until the stake is in focus. As you look through the crosshairs, you'll want to focus these up as well. And in order to do that, you'll need to turn the eyepiece. In order to keep eye strain at a minimum, try keeping both eyes open while sighting through the telescope. Once the general focus is completed, sight the scope on the nail head in the opposite front corner. Next, tighten the horizontal clamp screw to keep the telescope from moving. Now, with the telescope secured and in place, turn the horizontal circle scale to 0. After that's been completed, move back to the horizontal clamp screw, loosen it, and then rotate the telescope until the horizontal circle scale reads 90 degrees from 0. Next, retighten the horizontal clamp and drive a stake. This stake should be located on the rear building line. To check the accuracy of our work, go back to the telescope and take a second look. The stake should line up with the vertical line in the crosshair. To finish the job, drive a nail in the top of the stake, and you've just marked the rear corner of the building.
Let's use the 3-4-5 method to locate our final corners. We'll start at a front corner and using a tape measure, measure 3 feet back. Now, when you use this method, you can use any multiple of 3, 4, 5, like 6, 8, 10 for example. Using longer multiples will give you a more accurate reading.
If you're using 6, 8, and 10, measure from one mark to the other mark until you've measured out exactly 10 feet. This will create a perfect 90-degree angle. Now, following the already established line, measure back to the corner of the building and place a stake with a nail to mark the corner. To measure the fourth corner, we'll need to use 2 tape measures. First, measure from the front corner to the rear corner. After you've made this measurement, continue to measure from the rear corner over to the other rear corner. Then place a stake and drive a nail, and you're finished.
To check the accuracy of our work, we'll measure diagonally, keeping in mind that these measurements need to be identical. Another way to obtain these readings is by using the Pythagorean theorem. This is a mathematical formula that goes back over 2,500 years and states that if you know the length of 2 sides of a right triangle, you can figure out the third by using the following equation. A squared plus B squared equals C squared. After all of your corners have been set and the location of the house has been calculated, we can move ahead and install the batter boards.
Batter boards are wood frames to which the layout lines are attached. 3 pieces make up a batter board, 2 stakes, and a horizontal piece called a ledger. Ledgers are usually 1x6s and are attached to the stakes in a level position. The top of the ledgers will usually be the same height as the foundation wall or the finished floor elevation. We still need to excavate the property, so keep this in mind when placing the batter boards. Try to place batter boards 4 feet from the excavation site. Once you've set the batter boards in place, they should never be moved or shifted.
So, how high do we need to set the ledgers on the batter board? Well, in order to determine the height, we need to know 2 things: the proposed finished floor elevation and the location of the benchmark. This information can be found in our plot plan, so let's take a look.
The benchmark, which is often marked BM on the plot plan, is an object that's unlikely to move during the course of the construction. The center of the road, a fire hydrant, or a manhole cover would all qualify as benchmarks. After locating the benchmark, set up a transit level at about the center of the building location and sight it to the benchmark. Record the sighting and determine the difference between the benchmark sighting and the height of the ledgers.
Right down a little bit.
This difference should give us our elevation, which means we can go ahead and sight the elevation and attach the ledgers. First, sight and mark each corner stake at the specified elevation. Next, attach the ledgers to the stakes so that the top edge of each ledger is on the elevation mark. Here's something to keep in mind. When it comes to attaching ledgers, it's usually easier to use wood screws rather than nails. Nails have a tendency to shift and loosen the stakes.
After the ledgers are attached, feel free to brace the batter boards for some added support. Okay, that was one way to level ledgers. Here are a few other examples. Using a water level is a great way to level out ledgers. To use a water level, measure the difference in elevation from the benchmark to the desired height of the ledger and mark that measurement with a stick. This is a water level. It's nothing more than a clear plastic hose filled with water. In terms of diameter, a clear hose that's a ½ inch in diameter works really well for this job. Now, before you begin, make sure that the water level has no kinks, blockages, or air bubbles. The water level also needs to be opened on the outside on both ends.
A drop of food coloring in the water makes it easier to see the water level in a clear plastic tube. Here's where the science comes into play. Since water seeks its own level, water at both ends of the hose will stop at the same elevation. So, we move the water level until the water lines up with the desired level on the stick. Then, we'll move over to the opposite end of the hose and mark the stake at that height. And there you have it, a leveled off ledger using a water level.
If you really want to use some state-of-the-art technology, then a laser level is a great way to level off a ledger. A laser level emits a straight line, well, actually an absolute straight line that can only be interrupted by an obstruction.
Using any type of laser technology requires special care. So before we demonstrate how to use a laser level, let's go over some safety issues. First, never stare directly into a laser beam or look at it using an optical instrument. Next, whenever possible, set the laser above or below eye level. Always remember to turn off the laser when it's not in use, and never, I mean never, point the laser at another person. Unlike other levels, a laser level requires only one person to operate it, making it a perfect tool when working alone.
Now that we've gone over the safety rules, let's give this piece of technology a try. A laser level is mounted and leveled on a tripod in the same manner as an optical transit level.
When the laser is on, it emits a red beam of light that rotates 360 degrees, creating a perfect level plane of light. Lasers can be pretty difficult to see outside, so a sensor target is attached to the leveling rod to help us detect the beam. The sensor itself can be either visual or audible. If we were to use an audible sensor, the sensor would emit fast beeps if the target was above the laser beam, and slow beeps if it was below the target. The key here is to adjust the elevation until the sensor emits a nice, steady tone. To set the elevation of the ledgers, shoot the benchmark while adjusting the target. Next, move the target up or down the rod and note the difference between the benchmark elevation and the ledger elevation. In this instance, it happens to be 18 inches. Finally, shoot the ledger height by moving the rod vertically until the laser indicator is centered, and then mark the bottom of the rod.
Once you've determined the elevation of the batter boards, it's time to move on to the last phase of the building layout process, and that involves stretching the lines between the boards and directly over the nail heads located on the original corner stakes.
First, we'll need to locate the position of the lines, and we'll find that position by suspending a plumb bob directly over the nail heads. Next, make a saw cut on the outside corner of the top edge of the ledger. This will prevent our layout line from moving once it's been stretched and secured. Before securing the line, it's always a good idea to check the accuracy of the layout by measuring the diagonals to see if they're equal.
77 feet 1 1/2 inches.
At the same time, you should also grab a transit and check the elevation as well.
Okay, check the other one.
If the diagonals are not the same, then you'll need to make adjustments before moving on.
Okay, good.
Once you've checked the diagonals, begin attaching the string. Attaching the string will give us an outline of the building walls that intersect at the corners. In order to get the layout as accurate as possible, you should use a plumb bob throughout the process.
Alright, let's measure the string dimensions and finish this job up. First, take the tape measure and hold it at 1 foot. In the end, this will be much more accurate than trying to hold the tape at one of its own ends. You just need to make sure that the person at the other end knows that you're doing this so they can adjust the readings accordingly.
For accuracy in measuring, try straddling the string. Hold the 1 foot mark on the string and place your forearms on your knees for support. It's important to remember that while you're stretching the line, that the strings remain tight and that nothing is touching them, including your fingers. Once the exterior perimeters of the building have been established, measure the diagonals one more time to make sure that the corners are square, and we're done. The batter boards are now in place and the building layout is complete.
Well, that completes the first program in the series. Laying out a building requires both patience and precision. With our building all laid out, we're ready for the next phase of construction, setting the forms. We'll cover that material in our next program. I'm going to call it a day. For Del Mar Learning, I'm Rodney Wiltshire, and I hope to see you back on the job site real soon.